Okay, welcome back. What I want to do is to look at mathematics matrices. Okay, and the idea of this is to make us aware of the uses of matrices and how to resolve them. Okay, now again here we're looking at matrices, okay, mathematics and GCSE level. Okay. Now matrices. Now a matrix is a rectangular display or array of numbers arranged in rows, horizontal, and columns vertical, which is used to present information. It is enclosed by a large pair of brackets. The plural of matrix is matrices. Arrays of numbers have been used to present information or could have been used to present information in previous units. Okay? Now in Unit 9, Unit 9 is not relevant to you because you haven't read Unit 9, so you don't need to worry about it, but it's purely been used as a point of reference and point of reference only. Okay? Simple interest, compound interest, table on page 8 is an array of numbers. Part of the table is shown below. And all we're doing here is showing you part of the table below here. Years, 5%, 6%, 7%. And this will be the growth in respect of your annual interest rate, which would be applicable. Okay. Now look carefully here that you have your row going across and your columns coming down. Now, if this table were being used by those who understood its purpose, the wrong column headings could be removed. Okay? Could be removed and the number array presented as a matrix with 5 rows and 3 columns. Therefore, it would be a 5 by 3 matrix. Okay? Okay, all this is now showing you is the columns and the rows. Okay, and it's pointing to the 4th row. The matrix is said to be of order 5 by 3. The curved brackets around a matrix hold it together and show that it is complete. In reading the matrix, the number on the 4th row in the second column is 1.262, and this is the amount of interest which £1 would increase to if it had been accumulating interest at 6% for 4 years. Okay, I know it's not a lot of interest on a pound, but what can you expect? In Unit 11, and again ignore that this is just as a point of reference only, ratio and proportion, change of units, the information in some of the examples could have been presented in an array of numbers. excuse me. And all we're doing here is showing you how the information could have been presented. Okay, men, hours, days, etc. If the table is completed and the column headings omitted, finishing becomes a matrix with 2 rows and 3 columns. Okay. The matrix is of an order 2 by 3. 2 rows, 3 columns. Now, if we were to consider bar charts, pie charts, pictograms, deals with the collection of information, and you should all be familiar with these anyway, basically, okay? Or data and the presentation of that data in chart form. Very often, before chart is drawn up, the data collected is tabulated. On page 3 of the Unit 14, an array of numbers shows the number of children wearing different colored shirts. Okay? So what we're going to do, we're going to tabulate the different colored shirts to give us an idea as to how we can put our information into a form of matrix. Here is the colors: red, green, blue, black, white. Boys, girls, total. And we have our 3 columns of data. If the row and column headings are omitted, the array of data is presented as a matrix of order 5 by 3. 5 rows, 3 columns. Now the data has been collected from only one class of students. If the shirt colors of another class were noted and presented in the same way, the matrix might be 5 by 3. And here's your 5 rows, 1, 2, 3, 4, 5 rows by 3 columns. Okay? Both these matrices present data about a class of students, and the columns of shirts and the columns of shirts they wear. Columns and the color of shirts they wear. Ignore that, should be colors. Both matrices have 5 rows and 3 columns. In the second class, nobody was wearing a red shirt. The first row of matrix is 0, 0, 0. If this row had been left out, the second matrix would only have 4 rows, and it would not be possible to compare it directly with the matrix for the first class, because the matrix has to be comparable with each other, so there must be of similar rows and similar columns. So you cannot compare a 5-row matrix to a 4-row matrix. It will not be the same. It would not be clear from the matrix which row was missing. Including the 0 or null row makes it possible to combine the 2 matrices. Now remember, where there's zeros, it's a null value, nil, if you want to use that terminology, okay? To produce a third 5 by 3, in these matrices, the 2 numbers in the first row and the first column, 3 and 0, both represent a number of boys wearing red shirts. If they are added, 3 plus 0 equals 3, the total is the number of boys wearing red shirts in the 2 classes. Similarly, the 2 numbers in the 5th row and the 3rd column, 2 and 14, in the fifth row, two and 14, both represent a number of students wearing white shirts. If they are added, 2 plus 14 equals 16. The total is the number of students wearing white shirts in the two classes. These totals can be written in a third matrix, giving information about the two classes combined. And what we're looking at here is this and this. Okay? So this and this. These are two matrices which has given us our third matrix. Okay? Now you need to do a little bit of revision for yourselves, and you need to do a bit of groundwork as well for yourselves, so that you understand the concepts behind it in full. There's no shortcut to it. You cannot learn it off the screen. You write it out, make it your own. That is your job. Get it done. Matrices can be added. Now if they are of the same order, A5 times 3, a 5 by 3 matrix can only be added to a 5 by 3 matrix. It cannot be added to a 4 by 3 matrix, and if it makes sense to add them, matrix example taken from etc. 5 by 3, the matrix example taken from unit 14 is also of order 5 by 3. However, it would make no sense to add two together a matrix showing the growth of capital accumulating compound interest and one showing the clothes worn by students. The resulting matrix would have no meaning. Okay? To add matrices, corresponding numbers of elements in each matrix are added. So let's look at this. So what we're saying here is 3 plus 0, which we have here 3 plus 0, 12 plus 0, 15 plus 0. Okay? We have 2 plus 0, 3 plus 1, 5 plus 1, and this is what we have here. Okay? Now this is pretty simple enough. You can now see by adding these up, you've then created your 3 plus 1 is 3, etc. 7, 8, 9. You've created your final matrix from your end result of your previous two matrices. Each number or element of the new matrix has a meaning. The element on the fourth row in the second column is the number of girls wearing black shirts in the two classes. Okay. Now let's look at subtraction of matrices. We can also subtract matrices. Once again, matrices can only be subtracted if they are of the same order and if it makes sense to subtract them. To subtract matrices, the corresponding numbers or elements in each matrix are subtracted. And here we have our example. So 6 it's a 3 by 2. Okay. 6 So we're saying 6 minus 3, 4 minus 0, 2 minus 7, 1 minus 5, 3 minus 1, and 2 minus 1. Now because this is a minus here, a minus and a minus makes a plus, so that will end up at a 3 at this end. That is why we have a 3 here, and you will get a minus 5 in regards to 2 minus 7. Okay. Now make sure you write these out for yourself so you can understand the concepts behind it. I'm doing it on a screen. Okay. It may also be sensible to multiply a matrix by a normal number. Example, 3 children buy sweets each week as shown by the following matrix. Mars bar, Snickers, Bounty. To calculate the quantities of sweets bought during a year, we multiply each number in the matrix by 52. So if you multiply all this by 52, this is what you will get. Now you need to do this for yourself because there are sometimes errors in these calculations, and you need to identify those errors for yourself and rectify them. Okay. And I'm not going to say anything much on this further, but this is for you to do. Okay. And here we're using letters sometimes to represent matrices. Again, here what order is the matrix that is for you to answer, okay, and look back at the work previously. This matrix gives the same information for the following week. Okay? And here all I'm going to do again is go through this with you. Again, we've done the practice above, so you should not have any problem with this. Now, multiplication of matrices. The process of multiplying one matrix by another matrix is a little more complicated. In an earlier example, we looked at children buying sweets each week as described by the matrix. So we're going to use that data to show you an example as to how to multiply. For the price for the first week in January described as Jan price. Okay. Mars bar, Snickers, Bounty. Question: how much did Peter spend that week? And so Peter spends 3 times 20 plus 2 times 21 plus 4 times 22 equals 190. Notice that this process involves multiplying pairs of numbers and then adding. And you can see here that that is where we get our numbers from, where Peter. Okay. It's okay. I'm just going back to recap. I'm just recapping here now, okay? Okay, yeah. So here you have the total 190. Notice that this process involves multiplying pairs of numbers and then adding. Similarly, Joan spends 1 times 20 plus 5 times 21 plus 0 times 22 equals 125. Now do the calculations for yourselves. Okay? You must work these out for yourselves. Do not take it as read. You cannot do it on the screen. Do it on paper, old-fashioned pen and paper. And here you now have the result of this, bringing it together, which then brings this to here and gives our end result. Okay. I want you to understand and take the time to look for this for yourself. I don't want you to assume that it's just going to appear by magic. Okay, it's not. This has been laid out so you can understand it and follow the process. You must follow the process. You've done all this already. You should all be able to do multiplications by now. Okay. And here you have a simple example workflow. So work for the examples, write them up, make them your own. Okay, you cannot go wrong once you follow the example. I'm not going to work at the examples for you, they're there for you to do. Look at that process. Okay, and if you look here, it's simply showing you here that you multiply that by that, then multiply that by that, then that will be multiplied by that, and that will be multiplied by that. That's what it is simply saying. Okay. And again here, follow the examples through. Okay. And here, do the examples. I'm not going to be doing them for you. Okay. And you can see that here, the answer here is 1 and 0. 4 times 1 is 4. And 6 times 0 would be 6 times 1 would be 6. Okay, so this is your answer here to get that to multiplied out to this. This is your answer here, okay? And again, look for the working out yourselves, okay? And here are the answers. Okay, thank you. I hope you found that useful. Bye bye for now. Thank you.